Hi everyone, this is OpenAir. Today, what I will be going through with you is the request structure in our contract. We have two different contracts. One is the campaign factory contract and a campaign contract itself. I'll explain what each of them are meant to do. I'll explain the different scenarios that our code has to account for and the test cases that we have done to account for those scenarios. The test cases will be shown through remix. We have decided to use an IDE to compile a script, and we'll be demonstrating test cases um, through a video instead of through creating a test script. So without further ado, we have firstly the contract campaign design. The contract campaign is used by organizations to create instances of requests. Now, these requests can be used to transfer for supplies. They're used to make transactions to vendors, to get supplies, to perhaps donate or form events. And at the end of the day, they are to be voted for or against by contributors of the particular organization. How this works is that if the balance of those who voted yes is more than the balance of those who voted no, the contract, once voting period has expired, can be executed by the organization themselves. So if we look at the request structure, there is the description which contains why the request is created, the value which talks about the money that will be sent to the vendor, the recipient that contains the address of the vendor, a complete boolean uh, type that is true if request has been processed. This means that the default value is false. The approval count, which keeps track of the sum of donations of those who voted yes, and the rejection count, which does the opposite. And lastly, we have approvals, which is a mapping from address to boolean. This just keeps track of whether someone has voted. If they have voted, it will turn to true, and this tells us that they cannot vote again a second time. In terms of our variables, we have organization, which is the address of the organization that created a request. We have approvers, which is the list of addresses for every person who has donated money. We have amount, which keeps track of the amount each person has donated. We have requests, which is the list of requests that the organization has created. And we have contributor count, which is a uint type that talks about the number of donors uh, or people who have contributed for an organization. So what do we need to do is we had to create these functions in order to make our entire site work. So the constructor function is called when the contract is created, and this just sets the owner of the contract, which will be the organization themselves. There is the contribute function, which is called when someone wants to donate money. Any donor can donate money to the organization. There is the create request function, which can only be called by the organization when they wish to create a new spending request. Then there is approve request, which is called by each and any contributor when they want to approve a request. Reject request does the same thing, except it rejects a request instead. And lastly, there is a finalized request, which is called by the organization once voting period is over, and only if the sum of balance of those who approved the request is more than the sum of balance of those who rejected the request. So as an example, if two people have donated $10 each and they voted no for a request, and that means that they're $20 worth of a balance that represents no. However, if a third party comes by and decides to contribute 30 and vote yes, then the sum of the balance in those who voted yes exceeds the sum of balance in those who voted no, and therefore this will allow a request to be finalized after the voting period. This will be the introduction of our campaign factory, which is another contract that houses the campaign contract. A factory contract will allow an organization to create multiple campaigns, and the campaign contract will allow organizations to create multiple requests. And when both of these are combined together, you have a diagram that looks like this. So, in order to create a campaign factory, we only use the variables deployed campaigns, which is an address type that contains an array of campaign addresses. So if an organization like WFP wishes to create multiple campaigns, they can use this campaign factory. In terms of the functions, we have create campaign function, which is called when an organization wants to create a campaign, and we have get deployed campaigns, which is called when someone wants to find the contract address of a particular campaign. So right now we will demonstrate different edge cases. We will demonstrate the process of how an organization and its donors should expect to operate on our website. So say our organization wants to create a campaign. They will have to access the campaign factory contract, and through that contract, they will be able to create instances of campaigns. Say this account 5B3 is the organization itself, and it wishes to create a campaign. Its contract will be the campaign factory, and it will click on deploy. Immediately, what we see is that there is a deployed contract, and this is the campaign factory address. Right now, what we will do is we will first create a campaign, and then we will look at the first index of that particular campaign to get the address. So this address will be used to create our own campaign. We will just need to load this address to our campaign contract. And immediately you'll find that you have an instance of a campaign where you're now able to create requests for that particular campaign. Now, in the second scenario where an organization wishes to create requests, there are two scenarios that we have to look at right now. In scenario A, an organization creates requests, and this is perfectly fine. But if a random user tries to create a request, this is reverted because a random user is unable to create requests if it is not the owner of that particular campaign. And this is demonstrated through an example on Remix, where say the owner, which is 5B3, decides to create a request, say one donation to kids in Cambodia, for instance, and value would be in some random number. I'll just include it there in way, and the recipient will be the second address, let's say AB8, right? So you are not the account, if you are not the contract owner, right now this account is 0xAB, the contract owner is 5B3. If you're not the contract owner, this should not transact. Right now, I'm going to pull up the terminal. As you can see, the transaction did not transact. Again, just in case you didn't see it earlier, it did not transact because you are not the owner of this particular contract. However, if I did change it back to the owner and I chose to transact this, it will go through. So we know now that this code would account for this scenario. In the next scenario, we have approving and rejecting requests. So in scenario A, you have a contract, you have a campaign contract with a single request A. And in this case, you see that there are three individuals who have voted, right? And this is perfectly fine and normal. But in edge cases where there are circumstances and situations where the code does not account for a user who votes more than once. In this case, if C votes more than once, which is possible, then this entire scenario would fail. This is something that we have to account for. We have to make sure that our code requires that users cannot vote more than once. And how this is done is firstly by finding an address that has not done anything related to our current contract and contribute an amount. Say we want to contribute an amount in Wei, let's say 10 Wei. So this account contributes 10 Wei and the transaction goes through. He decides to approve of this request. And the request right now, since this is the first request, the index in our request array, in our request array would be 0, and therefore if we press approve request, it will go through. However, if we choose to do it again, it would not work because a user is only able to vote once. So our code accounts for this scenario as well. In this section, we'll talk about finalizing requests. So organizations can only finalize requests when the voting period is over and when the contributions of people who voted yes outweighs the contributions of people who voted no. So in scenario A, the contributions of people who voted yes is 210 Wei, which outweighs those who voted no. In scenario B, however, this is different. This scenario would not work because those who voted yes sums up to 110 Wei, and those who voted no sums up to only 200 Wei. So how would this be demonstrated? So for ease, we are going to create a new campaign, and we are going to find this address of this contract. We are going to load it, and we should have the contract details here. So again, the owner will have to create a request. Let's say donate food to people with 50, they want to donate 50 Wei, and the recipient will be again some random address. The recipient will be some random address. And right now, what will happen next is we follow the diagram below. So somebody decides to give 10 Wei and voted yes. They've shown that they've contributed 10 Wei and they have chosen to approve this request. So they've shown that they've chosen to approve this request as shown. And right now, what will happen next is another person decides to come in. He decides to contribute 200 Wei and vote no. So 200 Wei contributes that, contributes that. He decides to vote no, and the transaction goes through. Now we have another party who comes in and decides to donate 100 Wei, 100 Wei, and votes yes. So this person contributes, and then this person approves the request. Now, the owner will try to finalize this request, and the expected answer is that it should not be available. As you can see, it did not work. So now we're gonna see if it would work if another address were to come in and donate, say, 500 Wei, 500 Wei for ease. This person chooses to approve the request. So now we have a majority of people, a majority of balances that is approving this request. As we finalize this request, we have shown that this scenario has been accounted for, and therefore contributions to people who voted yes, if it is lower than those who voted no, this scenario would not happen. The contract would simply revert the ability to finalize the request. In the next section, we talk about request completed. So once a request is completed, it will be sent over to a vendor. And this value can only be sent once, it cannot be sent twice. That is to say that a request can only be finalized once. It cannot be finalized twice, and therefore the value cannot be sent twice. So if the organization decides to finalize the request again, the transaction would simply revert, therefore accounting for scenario B. So any organizations that wish to send the value twice will not be able to do that. Through this slides, I hope I've demonstrated what our code is capable of. There are a few limitations which will be discussed in GitHub. Thank you very much.